Okay, conditional probability. This is notation for the probability of an event B happening given that A has already happened. Naomi's playing a game with the spinner shown. What's the probability that the spinner lands on a 7 given that Naomi has spun a number greater than 5? There are 8 possible results on the spinner shown. Let event A be that she spun a number greater than 5. Well, there are 3 numbers out of 8 that are greater than 5. That's where they got the 3 8s. Let event B be that she spun a 7. There's only 1 number out of 8 that are a 7. The probability of B given A has already occurred is this lovely formula, probability of A and B divided by the probability of A. So they wrote 1/8 divided by 3/8. And if you did that division, you would change to multiply by the reciprocal, which is 1/3. So they got the answer 1/3. The probability of spinning a 7, given that the spin is greater than 5, is 1 in 3. Do you really need this formula to do that problem? No, you don't. Okay, so if we just used our heads and we went, what is the probability of, and I'll explain how I would think it out without doing the formula. But probability of B given that, probability that the spinner lands on 7, given that Naomi spun a number greater than 5. Well, if you think about it, how many numbers are greater than 5? 3 of them. Well, how many of them are 7s? 1 and 3. That's how I'm going to do problems. Okay, I'm not going to use this formula. All right, so cards are drawn from a standard deck of 52. Find each probability. The card is a heart, given that an ace is drawn. So you always want to look at this part first. If an ace has been drawn, how many aces are there in a deck? That would be on the bottom, okay? And then you say, what's the probability that that card would have been a heart? 1. Okay, 1 in 4. Probability that a card is a 6 of clubs, given that a club is drawn. You are given that a club is drawn. How many cards are clubs in the deck? Okay, so that's on the bottom, 13. So it's going to be out of that amount. Now, what's the probability the card is the 6 of clubs? How many 6 of clubs? There's only 1 of them. 3. The card is a spade, given that a black card is drawn. Now we're given that a black card is drawn. How many black cards are there? 26. Okay, and then if it's a spade, how many of them are spades? 13. So then reduce 1/2. A 6. Now we're working on a die. We got a 6-sided die, so there's 1 through 6 on the die. Find each probability. A 4 is rolled, given that the roll is even. So first we want to think about what numbers it's out of. So the bottom number will be, how many are even? Yep, 3 of them. And how many of them would be 4? 1 of them. Okay. A 2 is rolled, given the roll is less than 6. How many numbers are less than 6? 5. And how many is a 2? 1. Pretty easy. Okay, probability an even number is rolled given the roll is a 3 or a 4. 3 or a 4, there are 2 numbers that's just 2 numbers. One is a 3, one is a 4. Add them together, you get 2. That remember or means to add. And then probability that it's even would be only one of those is even. Okay, on the back. Contingency. A contingency table is a table that organizes the data. It's got data in which different possible situations result in different possible outcomes as well. These tables can be used to determine conditional probabilities. Find the probability that a student plays lacrosse given that the student is a junior. Okay, ignore the formula, please. I'm just going to, oh, by the way, there's a mistake in this totaling. Did anybody look in here? It says there are a total of 2,180 students. And then I looked at these numbers and I said, well, where'd that 14 come from? What should it be? Yeah, there was, and then this was out of a textbook thing, so I don't know how that happened. But anyway, or maybe it was added in. That should have been 2183. I'm going to add 3 to that. So anyway, I may not even need that anyway. Because if I'm not going to use the formula, I might not even have to know the total number of kids that are in this list. So I'm going to go, what's the probability? It says, she said that, the question was, find the probability that a student plays lacrosse given that student is a junior. Okay, so what do we need that? We need them to be juniors. So all we need to know is about the juniors, right? So how many juniors are there? There are 544. Okay, so 544. And then it says probability that they play lacrosse. So that would be 34 out of 544. So then we would reduce it. And you've got a calculator that can reduce for you. So take 34 divided by, I forgot, 544 was it? Then hit your math, enter, enter. And it'll reduce the fraction to 1/16. It is the same answer that they got down here, but it took them a lot longer to get to what they got to than it did for us. Okay, so I'm thinking this is the way to go. All right, oops, I missed that. Was this? No more questions there. All right, exercise. Try some other charts. That was the only one we did on that chart. Oh my gosh. The table shows attendance at a wedding. Find the probability that a person can attend the wedding given that the person's in the bride's family. All right, so we need to pay attention to only people in the bride's family for this question. And then it says, what's the probability that a person can attend? So we look at the can attend and we circle that. But how many people are in the bride's family? 136. So we got 104 out of 136. Let your calculator do the reducing if you like. Math, enter, enter. We got 13 out of 17. Now, if you wanted, you could even do this in a percentage form. If that were the way that you were doing a multiple choice test and percentages were given, then you would just divide those numbers and check out what the percent is. What worksheet number do you have labeled on here? Or do you have one? I think I took it off, didn't I? Okay. All right, let's go to the next one. We got baseball. The table shows the number of students who play baseball. Find the probability that a student plays baseball given that the student is a senior. So we just want to look at the seniors. So this time we're going horizontally. We'll see the total of the seniors first. That'd be 340. And then it says probability the student plays baseball, 34 out of 340. And that would reduce to 1 in 10. Okay, next example. Shopping. 4 businesses in town responded to a questionnaire asking how many people paid for their purchases last month using cash, credit cards, and debit cards. Find each probability. All right, we've got 4 different stores. We just want to read the questions, and then we'll figure out which way do we want to look, vertically or horizontally first, etc. A shopper uses a credit card given that the shopper is shopping at Jacob's Gas. All right, so we look at the last part, given that they're shopping at Jacob's Gas. That's going to determine the column we're looking in. So that would be this. And then we will discuss the probability of using a credit card. Credit card would be the middle one there, 456. We're going to need to know how many people shopped there. We're going to have to total these up. So that's, someone do that for what, 460, 760, 1,000 what? 1,120. Okay, and then we'll let the calculator do the reducing. 456 divided by 1,120. Oops, I got too many numbers. Oops, I did a decimal. So if you had a decimal, it'd be about 41%, or math, enter, enter, reduced to 57 over 140. or 41%. A shopper uses a debit card given that the shopper is shopping at Pet Town. Okay, now we're going over to Pet Town. We need to look at the total for Pet Town's shoppers. We're going to add all those up. I've done it before. Is 147 what you're getting? Okay, and then it says uses a debit card. Yes. I thought it was 40 also, so I'm sorry. I went with what you told me. I'm sorry. I actually thought it was 1,142, and I swear somebody said 20, so I put it in. Let's fix that though. Okay, so when you reduced it, it was okay. Let me just. It was one. Yeah, this was 1,140. Okay, and then when I reduced, it wasn't that, was it? All right, so let me just recalculate just to make sure. 456 divided by 1140. And that would have been 40% instead, or reduced. You guys just told me it was 2/5. Yep. And 40%. 2/5 or 40% if you were talking about percentages. Okay, now back to where we were, Pet Town. The total is 147. Okay, that is correct. Make sure I have written down what, and you're agreeing with me. Yes. That's because of what I told you to type in. That's if you put in 456 over 1120. I had that wrong answer because I asked for how much the total was, and I listened and said 1120. So we corrected it because the actual total is 1140. Okay. You okay? All right. So I got to look at debit card users for Pet Town finally. All right, we have 147 people shopping at Pet Town, of which 28 out of those 147 use a debit card. Okay, divide or reduce. You can divide by 7, which would be 4 to 21. And if you did a decimal, did anybody see what the percentage was? How much? 19 or a 19%? Okay. Finally, number C, letter C. Or is there more than that? No, just C. A shopper is shopping at TJ's, given that the shopper is paying cash. Okay, now, do not highlight TJ's yet. Which way do we need to go? You have to do this part, paying cash first. So we're going that way for this one. You have to realize which way you've got to read. You got to do the given part first. Cash is king. Anyway, and you're shopping at TJ's. So 102 people shop at TJ's paying cash out of how many people paying cash in all? So we got to add all those up. Now, when I added that up, I got 595. Is that what you're getting? Okay. So 102 out of 595. That does reduce to 6 over 35, or if you went ahead and got the percentage, 102 divided by 595. Oh, I hit times. In decimal, it's about 17.1%. Okay. This is your assignment. It's already picked up. I have it on the worksheet for you. I would start practicing it, and there's one in particular I'll probably help with. So I think I'm just going to pause this in case I go to that one. My 6th hour wanted me to go over these examples, and I don't think I might have had it in the recordings, so we're going to add it in. Example 2, first it says, how many ways can 8 students be placed in line? Would order matter? How many ways can 8 students be placed in a line? It would matter who goes first, second, third, fourth, etc. So that would be a permutation. Now, you don't have to use the formula to do this problem, but I'm going to show both. A permutation. Well, how many students are you placing in line? All of them, right? All right, so that'd be 8p8. Now, 8 permutations of 8 people. This way you could calculate it on the calculator, but I'm going to show you that it will mean, well, I'm going to plug it in. I want you actually to see something before I tell you how to do it on the calculator. The formula says that a permutation is an n factorial, which would be 8 factorial. The first number is 8 is an n, and the second one is your r value. And the formula says on the bottom you do n minus r, so that would be 8 minus 8 factorial. 8 factorial would be on the top, 0 factorial will be on the bottom. Now, what I need you to know is that there's a definition of 0 factorial that says it's 1. So don't think we're dividing by 0. We're not. All right, so actually, this would be 8 factorial divided by 1. And what 8 factorial means is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? If you multiplied all those, or if you used your calculator, and I'll show you where you can do 8 factorial, and I'll show you also where you can do 8p8. So if you go to math, arrow over to probability, P-R-O-B, 4 is factorial, and I think I have to put in the 8 first. Yep, see, so I have to put in 8, then I would have to go to math, arrow over to probability, choice 4, and then I could hit enter. 40,320. Okay, now that's how many ways that you could line the people up. Yes. Well, I'm going to show you another way to get it. So, math, over to the right. You use choice 2, which is what I said I was going to explain. I'm going to show it how you can do 8 factorial and also how you can do 8p8. If you hit choice 2, it gives you the boxes for you to put this in. Does anybody's calculator not do this for them? If you have an older calculator, it might not. You might have to put the 8 in first and then hit the choice. So no one's having a problem with that. So I'm putting in 8. I'm going to arrow to the right, put in 8, and then hit enter. That's what I was trying to explain to you. Simplifying it on your own ends up with being 8 factorial, which is what 8p8, that's what it's calculating. Now, I'm also going to explain this another way. Permutations are actually easier than the combinations. Think about this. How many did you really even need these formulas? How many ways can 8 students be placed in a line? How many choices for the first person in line? After that, how many choices for the second person? Third, you got the idea? Same thing. So, in probability, there's a lot of formulas. For certain situations, you don't really need that formula. You can do it with common sense, or just thinking about it and hopefully having some common sense about what you're thinking. How many ways can a group choose a committee of 4 boys and 4 girls if there's 20 boys and 15 girls to choose from? That's a combination. Okay. Now, you're going to have to multiply the 2 situations. Because one's about boys and one's about girls. All right, so if you've got a committee, you need 4 boys. You want 4 boys, and there are 20 boys. One of the combinations is 20C4. You can take it out of 20 boys. You're needing 4 of them. You're going to multiply that by the combination of girls you could have, which is 15 total girls, and you need 4 of them. Okay, so this is what we're going to need to type into the calculator. So we're going to use that probability button. We'll go to math, arrow to probability. Better type this in, please. 3 is the choice. We had 20 boys, 4 of which we want to choose. So I'll do 20C4. And I'm going to hit times. Oops, I can't put it there. I just realized something. Okay, so I'm going to delete that. I have to get out of here first so I can hit times. Now I can go back to math. Probability, choice 3. I had 15 girls, of which I'm choosing 4. Arrow over, put in the 4. This is a big one. 6,613,425. That's a lot of ways. Okay, and how many ways can I arrange my videos and DVDs on my shelf if I have 5 videos and 7 DVDs, and all the videos together and all the DVDs are together? Does order matter? Yes, it does. Permutation. All right, we've got 2 situations because we're going to do the videos and the DVDs separately. If the videos are all together and the DVDs are all together, this won't be as complicated as it would be if they weren't. We're going to do 5 permutations of 5 times 7 permutations of 7. You're putting them all on the shelves. Now you can do this with the probability under math probability, or you could actually think this one out like this. How many ways can you arrange the videos? Well, how would be the first video would be 5 ways, second 4. This is also can be done by the counting principle. 5 times 4 times 3 times 2 times 1, and then you'd multiply that by 7 times 6 times 5 times 4 times 3 times 2 times 1, but clearly it's faster if you use your calculator probably. You can go to math probability. 2. Put in 5 and 5, and then on the other one times, we'll have to arrow out of there, hit times. Now we'll put in 7, P7. If I can find math. And it's pretty big. $604,800. Hope that helped. So you're going to know that you're probably going to be able to do the counting principle on worksheet 82, which is on permutations, and on 83, the combinations. You'll need to do the formula in the calculator.